Hi everyone, this is our lecture video for section 7.6, where you are looking at applications of rational equations, in particular when dealing with proportions. So in this section we're going to be dealing with word problems that have situations modeled by proportions. A proportion is a statement of equality between two ratios. Recall that ratio refers to fractions. The vast majority of the problems that I assigned from this section are going to be proportion problems involving similar triangles and also the distance formula. So let's take a look at an example from each of those two groups. Number 1. A tree casts a shadow that is 12 feet long. At the same time, a vertical rod 8 feet high casts a shadow 6 feet long. How tall is the tree? Okay, so these two triangles that are drawn here for this word problem, they are going to be right triangles. Right triangles are similar triangles. What is the important fact of similar triangles that you need to remember? For similar triangles, you have the following. So ignore the black just for a moment. For similar triangles, you have that the ratio of any two sides of one triangle, if it is similar to another, it must be equal to that exact same ratio of the corresponding sides of that other similar triangle. So in this example here, if I look at the smaller red triangle and I look at the ratio of A over B, this has to be equal to the ratio of C over D. Another thing that you can do is the following. For similar triangles, if you look at the ratio of corresponding sides of two similar triangles, so in this case here, if I look at the hypotenuses of these two triangles, you must have that ratio is equal to the ratio of any other two corresponding sides of the two triangles. So I could say that G over H is equal to little a over C, for example. Okay, so applying that here to this problem then, we have the following. We have that the ratio of H over 12 is equal to the ratio of 8 over 6. Multiplying both sides by 12, we will have solved for H. Multiplying that out, you should end up with H equals 16 feet. Moving on to the next problem, we have the following. In still water, a boat averages 15 miles per hour. It takes the same amount of time to travel 20 miles downstream with the current as 10 miles upstream against the current. What is the rate of the water's current? So this is a problem that is going to involve the distance formula. The distance formula, D represents distance, R represents the rate, and T represents time. The distance formula is D equals R times T. So in this particular problem, we know the rate of the boat. We do not know the rate of the water current. So I decided to let a variable R sub W denote the rate of the water current. So we know that when this person goes upstream, the rate of the boat stays the same. So it says here that they travel 20 miles. Oh, I'm sorry. When we go downstream. So when we go downstream, we're going 20 miles. And if we're going downstream, we're going with the current. So the rate of the boat, which is 15 miles per hour, is being aided by the current, which we don't know. When we go upstream, we're going 10 miles upstream, we're going against the current. So the rate of the boat is going to be subtracted by the rate of the current. So I have some typos here. Let me just fix them. We know that the time that this person goes 20 miles downstream as 10 miles upstream is the same. I don't know what that time is. I'm just going to call it T. So in this problem, you have two equations and two unknowns. But for this problem, you just need to find the rate of the current. So I'm just going to focus on solving the rate of the current. So I set up the D equals R times T equation for both downstream and also upstream. So since I just need to find the rate of the current and we don't care about how long it takes to travel these distances, what we're going to do is we're going to solve for T in each of these equations. If we solve for T in each of these equations, we have the following ratios here. Since both of these ratios are equal to the same variable T, by transitivity we may set them equal to each other, which will provide us with the following equation here. Now what do? Now we just need to solve a rational equation for that variable R sub w. So how do we do this? Based off of the last lecture, what do? We have a rational equation. The first thing that we want to do here is we want to get rid of the fractions. The LCD of these two fractions will be the products of the denominators. So that's 15 plus R sub w multiplied by 15 minus R sub w. So multiplying that out, we have some sweet cancellation here. Using our distributive property, we can multiply that out and see what we get. So here I have 300 minus 20 R sub w equals 150 plus 10 R sub w. And then we just move all of our variable terms to one side and the non-variable terms to the opposite side. Bam, bam. So I have 30 R sub w is equal to 150. So solving for R sub w, we're going to end up here with 5. Now 5 what exactly? So the numerical value is 5. But I'm going to write down the units here because this is a word problem, right? So the rate of the boat was in miles per hour. So this R sub w, the rate of the current, will also be in miles per hour. So our answer here is 5. I'm just going to write mph. Alrighty, everyone. That's going to wrap up this lecture video, and I will see you tomorrow.